We're going to talk about an infinite sequence. So an infinite sequence is a sequence, which is just a list of numbers with no ending term. So each term number is represented by n. So n is 1, that's term 1. If n is 5, that's term 5. So if n approaches infinity, that means we just keep going. There's never an ending term. So an example, if a sequence can be represented by 1 over n, then term 1 is 1 over 1. Term 2 is 1 over 2. Term 3 is 1 over 3. Okay, so these numbers in this case keep getting smaller and smaller because the denominator is getting bigger and bigger. And eventually, you're working toward 1 over infinity, which is extremely small. In fact, it's very close to a value of 0. Okay, so it gets infinitely small and it gets infinitely close to having a value of 0. So a sequence, as it extends to infinity, so where n is infinity, its value will either have no limit, so maybe the first term starts right here, and the next term is here, and the next term is here, and it keeps going this way, and the values become infinitely large. It could also start anywhere. We'd say it starts here, and the values are going this way, where as the term value approaches infinity, it just keeps getting lower and lower as a negative, so that term value becomes infinitely small. Or it could approach some limit. Say it starts here, and it's going to approach a limit right there, so the terms could level off and get infinitely close. Like this sequence right here was getting infinitely close to 0. So this is one that would approach a limit. Okay, so what is 1 over infinity? Well, it's really nothing. It's really close to 0, but it's not actually 0. So instead of 1 over infinity, we say this: a limit as n, the term number, approaches infinity. So as that term number gets larger and larger, we'll use that same sequence, 1 over n. So the limit for this sequence, 1 over n, as n gets closer and closer to infinity, is 0. So 1 over infinity does not equal 0, but as this n gets closer and closer to infinity, it approaches a limit of 0. It's infinitely close to a value of 0. So we're going to find the limits of these three sequences here. So this right here just represents a sequence. So does this, and so does this. It's just an expression for a sequence. Okay? So this right here is just a sequence. Okay? Then as n approaches infinity, so that means you've got term 1, your first term, your 5th term, your 100th term, your 1,000,000th term, your 1,000,000th term, going toward infinity. So as we just keep getting one term after another, does the value of this sequence approach some limit? But when I only have one term in the denominator, I'm going to split that denominator to help me find that limit. So I'm going to write the limit as n approaches infinity of 6n over n plus 1 over n. And 6n over n simplifies to 6. So it's the limit as n approaches infinity of 6 plus 1 over n. Now let's think about as that term number gets bigger and bigger. For term 1, this part is 6. For term 10, this part is 6. For term 1,000,000, this part is just 6. So as n grows, it does not affect that 6 at all. That's going to stay a 6. But as n gets bigger, it does change this fraction. You've got 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. And it goes on. 1 over a million, 1 over a billion, 1 over a trillion. This is getting smaller and smaller and smaller, getting closer and closer to a value of 0. So if I add these two parts together, I find that the limit that it's approaching is 6. So what this sequence would look like in a graph, it's got its limit up here of 6. Now the first term, 6 times 1 plus 1 over 1, that first term would be 7. So the first term is right here. And from there, the terms just get smaller and smaller and smaller, but approaching, and it will never actually equal 6, but it will get infinitely close to a limit of 6. Okay, our next one, once again, I've got one denominator here, so I can split that. The limit, one term in the denominator, not just one denominator. The limit as n approaches infinity of 6 over 2n minus 3n squared over 2n. So I can simplify that. 3n over 2. Okay, so as n gets bigger, I've got 6 over 2 times 1, that's 3. 6 over 2 times 2, so now it's 6 over 4. And then 6 over 2 times 3, now I've got 6 over 6. 6 over 2 times 4, now I've got 6 over 8. The number is getting smaller and smaller, and as that denominator continues to grow, this right here is going to reach a value, or it's going to approach, not reach, it's going to approach a value of 0. And I've got minus 3 times 1 over 2 is 3 over 2. 3 times 2 over 2 is 6 over 2. 3 times 3 over 2 is 9 over 2. So this time you can see this number is getting larger. And as n gets bigger and bigger and bigger, this fraction is going to continue to get bigger, and it's going to approach a value of infinity. So I've got 0 minus infinity, which is negative infinity. Okay, so that is my limit. It's going to approach negative infinity, which actually, I shouldn't even put a box around that, because what I should say is negative infinity, that's not even a thing that it's ever going to be able to reach. So it actually has no limit. If it's approaching infinity, that means there is no limit. Okay, so the first value in this, if I put in a 1 for the n's, I'm going to have 6 minus 3 times 1, which is 6 minus 3. So I've got 3 over 2. So the first term has a value of 3 over 2. 3 over 2 is right there. It's 1.5. And from there, it just gets smaller and smaller, approaching negative infinity. And it's just going to continue forever, which is why it has no limit. This one can't cross a certain line, so it has a limit. This one just continues going down forever, so it has no limit. Now this last one's a little bit different because there are 3 terms in the denominator, not just one term like we've had before. So I can't really split this one quite so easily. So what I do is look for the greatest exponent in the denominator. And it's right there. Greatest exponent in the denominator, it's n squared. So I'm going to multiply the numerator by 1 over n squared, and I'm going to multiply the denominator by 1 over n squared, and that's going to help me find the limit. So it's the limit as n approaches infinity of 6n, I'm going to distribute this, 6n over n squared, which is 6 over n, plus 3 over n squared. And then I'm going to do the same in the denominator. 2n squared over n squared is 2. N over n squared is 1 over n. and then minus 1 times 1 over n squared is 1 over n squared. Now I'm going to find the limit for each term inside of this fraction. So as n gets bigger, this denominator gets bigger, which means it's going to approach, this portion is going to approach 0. As n gets bigger, this denominator gets bigger. Anytime it's the denominator that's getting bigger, it's going to approach 0. There's no n here, so this 2 is just going to stay 2. Plus n in the denominator, as n gets bigger, that will approach a value of 0. Minus, as n gets bigger, that denominator gets bigger, so this will approach a value of 0. So I've got 0 over 2, which has a value of 0. Right? Now, I want to know the value of the first term. So this is my answer, but I want to illustrate it. If I put in a 1, I get 6 plus 3 over 2 plus 1 minus 1, which means I've got 9 over 2. So my first term has a value of 4.5. So it would be somewhere around right here. And from there, I'm not going to give exact term values, but from there, they go down and they approach and get infinitely close to, but never reach a value of 0. So it can never reach 0, so the limit is 0.